Assalamualaikum. My name is Muhammad Arif. Now I want to present the introduction. Wind power regeneration is renewable energy technology that harnesses the kinetic energy of moving air to produce electricity. It is one of the fastest growing energy sources worldwide, helping to reduce defensive depends on fossil fuel and lower greenhouse gas emissions. Wind energy is sustainable, clean, and widely adopted in both developed and developing countries. Okay, now for the basic construction of wind turbine, needs is rotor blade, gearbox, nacelle, generator, power cable, towers, transformers, and switchyard.
Assalamualaikum and good day everyone. Today I will be presenting the main components and the basic operating principle of a wind turbine. In total, there are 7 key components. First, we have the rotor blades, which function to capture the kinetic energy from the wind and convert it to rotational motion. Next is the gearbox. This component is responsible for increasing the rotational speed from the slow moving blades to a higher speed suitable for electricity generation. The third component is the nacelle, which is the housing or protective structure at the top of the tower that contains the gearbox, generator and control system. Inside the nacelle, we find the generator, consisting of a stator and rotor, which converts the mechanical energy from rotating shaft into electrical energy through electromagnetic induction. To ensure safe and efficient operation, the control system monitor wind speed, direction, and overall turbine performance. All of these components are supported by the tower, which hold the nacelle and blades at optimum height where wind speeds are stronger and more consistent. Finally, a transformer steps up the voltage of the generated electricity so it is ready for transmission through power lines to the grid. Next, how do all of these components work together to produce electricity? First, the wind blows against the rotor blades, causing them to spin. Second, this rotation is transferred by the main shaft as mechanical energy. Next, the gearbox steps up and increases the rotational speed. After that, the generator, utilizing its rotor and stator, converts this high-speed mechanical energy into electrical energy. The generated electricity then flows down through power cable located inside the tower. Before it travels a long distance, a transformer steps up the voltage. Finally, the electricity is successfully transmitted to the power grid for everyday use in homes and industry.
My name is Muhammad Adib Farhan. So this slide show a horizontal axis wind turbine, commonly known as HAWT. It is the most widely used type of wind turbine for electricity generation around the world. The rotor blades rotate around a horizontal axis and must face directly into the wind to operate efficiently. When wind strikes the blades, kinetic energy is converted into rotational motion, which drives the generator to produce electricity. So HAWT are commonly installed in large onshore and offshore wind farms because they offer high efficiency, high power output, and reliable performance in areas with strong and consistent wind speeds. And for the next slide, show a vertical axis wind turbine or VAWT. Unlike horizontal axis turbine, the blades rotate around a vertical shaft, allowing the turbine to capture wind from any direction without needing to turn forward the wind. This makes the design simpler and more suitable for location where wind direction changes frequently, such as urban environment. So in addition, maintenance can be easier because some components are located closer to the ground. However, vertical axis turbine generally have lower efficiency and lower power output compared to horizontal axis turbine. So despite this limitation, they remain a useful option for small scale and specialized application.
Now that we have covered how a wind turbine works and what goes on inside it. Let's take a look at how this technology is actually deployed in the real world. Generally, wind energy farms are divided into multiple categories based on their location, which you can see right here on this slide is an onshore wind farm. As the name suggests, these wind turbines are built on land. They are typically situated in hilly areas, wide plains, and coastal regions where the wind blows strongly and consistently. The biggest advantage of onshore wind farms are that they are much more cost-effective to install, easy to operate, and significantly simpler to access for regular maintenance and repairs. Moving on to our next slides, we have the other type of deployment, the offshore wind farm. Unlike onshore farm, these massive turbines are installed out at sea or in large body of open water. Now, you might wonder, why we build them out in the oceans? The reason is simple: energy potential. Wind over open water is significantly stronger, faster, and much more consistent because there are no physical obstacles like buildings or trees to slow it down. While the engineering challenge and maintenance costs are definitely higher out in the open sea, offshore wind farms make up for it by generating massive amounts of clean, highly efficient electricity to power our grind.
Hello, my name is Fabian Lester Napilip. My matrix number is 13231027. Alright, I want to talk about offshore versus onshore wind farm. The difference. For offshore wind farm, they have a stronger and more consistent wind. They also high energy output but more expensive to build and maintain. They also required a specialized foundation and marine transmission system. For onshore wind farm, it easier to construct and maintain and have a lower cost per turbine, but limited by land availability, noise concern, and lower wind speed compared to offshore. This is one of example of wind power generation at Pulau Perhentian, Malaysia. A small scale of onshore installation designed for island electricity needed. Demonstrate Malaysia exploration of wind energy despite relative low average wind speed. Useful for showing community scale renewable project in a tropical region. Okay, I want to show about a world largest offshore wind farm located at the North Sea at Hornsea Project, UK. It can generate electricity for over 1 million homes. The scale and efficiency of offshore project in a region with a strong and constant wind. That's all from me. Thank you.
Wind energy has several clear advantages. First, it is renewable and sustainable because wind is an infinite resource. Unlike fossil fuel, it doesn't run out. Second, it helps reduce greenhouse gas emission, making it a cleaner alternative that protects our environment. Once turbines are installed, operating costs are relatively low, and this industry also creates local jobs in manufacturing, installation, and maintenance. However, there are also disadvantages we must consider. Wind power is intermittent. Electricity generation depends on wind speed and consistency. The upfront capital cost for turbine and infrastructure is high. In addition, wind farm can cause noise and visual impact on nearby communities, and onshore project requires large land areas. In conclusion, wind energy is a clean and renewable resource that reduces dependence on fossil fuel while cutting emissions. Both onshore and offshore wind farms provide scalable solutions. From small community projects to large installations, although challenges such as intermittency, cost, and land use remain, ongoing technological improvement continue to enhance efficiency. Overall, wind power is an essential part of the global and Malaysian transition towards sustainability energy.